Welcome back to the deep dive. Today we are tackling a topic that honestly usually makes my brain just try to protect itself by immediately shutting down.
Oh boy.
We are talking about cloud security. And I know as soon as you say that, people picture like a guy in a hoodie typing in a dark room, or maybe more accurately, a mountain of compliance paperwork.
Yeah, that's a really good way to put it. You go in expecting the matrix, and what you really get is a building code inspection.
Exactly. And looking at our source material, these notes from AWS Practitioner 204, it's full of terms like WebF, NACL, ACM, SGs, just a total alphabet soup. But our mission for this deep dive is to see if we can turn that soup into, a functional blueprint, because this isn't just jargon, is it? This is the structural integrity of the internet.
It really is. And for the learner, the key isn't memorizing the acronyms. It's about understanding the architecture. Think of it like a blueprint for a fortress.
Fortress, I like that.
We're going to walk through the layers. You have the perimeter fence, the guards at the gate, the locks on the doors, and then, the rules of the kingdom.
Okay, let's jump right in then. The first section of these notes deals with what I think is the single most confusing battle in all of AWS networking.
I know exactly where you're going with this.
NACLs versus security groups. People trip over this constantly because they look identical, right? They're both firewalls, they both stop bad stuff. So why on earth do you need two?
It can feel that way, but it's not redundancy. It's defense in depth. They just operate in different realities, different altitudes in your infrastructure.
Okay, so let's unpack that. Where does the NACL live?
The NACL lives at the subnet level. If we use your fortress analogy, or maybe a gated community is better, the subnet is the street your house is on.
The whole street.
The NACL is the guard booth at the entrance to that street. Every single car, every packet of data has to stop at that guard booth first.
Before it can even get to my specific house.
Exactly. It's a broad filter for the whole neighborhood. Got it.
Yeah.
Now, the notes really emphasize a weird characteristic here. NACLs are stateless.
And this is the most critical concept. It's where most people accidentally break their own networks.
Stateless sounds philosophical. Does it just mean the NACL has a bad memory?
It means it has no memory. Total amnesia. Imagine you're in your house and you order a pizza. You send a request out. The NACL guard lets your request out because you have an outbound rule.
Right. Makes sense.
But 20 minutes later, the pizza driver shows up. He pulls up to the NACL, and the guard just looks at him and says, "I have never seen you before in my life."
Even though I just called him?
The NACL doesn't know that. It doesn't track the state of the conversation. So unless you have a separate inbound rule that says pizza driver is allowed, he's getting blocked.
Wow. So stateless means you have to manually approve the return trip for everything.
For everything. In technical terms, your server talks out, but the internet replies on what's called an ephemeral port, a temporary high-numbered port. You have to write rules for both directions. That's a lot of work. That sounds incredibly inefficient. Why even use them then?
Because they have one superpower that other firewalls don't. The NACL can explicitly deny traffic.
Meaning I can write a rule that says, block this specific IP address.
A hard ban. Exactly. If you have a known bad actor,
Yeah.
This is where you stop them before they even get close to your servers.
Okay, that is useful. A hard stop. Now, the rule book part of the notes, it mentions this numbering system. Rules start at 100, then 110, 120. Why the gaps?
Yeah, that's for your own sanity later. NACLs process rules in strict numerical order, top to bottom. As soon as it finds a match, it stops.
It stops reading the list.
Completely. So if rule 1 is deny everyone and rule 2 is allow Bob, Bob's never getting in.
Right.
Now, imagine you number them 1, 2, 3, and you suddenly need to insert a new rule between 1 and 2.
There's no number between 1 and 2. I'd have to rewrite the whole list.
You got it. If you use 100, 110, 120, and you need a new rule, you just make it rule 105. It's wiggle room for future panic.
Ah, smart. Okay, so that's the NACL, the amnesiac street guard. Now let's go to the house itself, the security group.
Right. If the NACL is the street guard, the security group is the lock on your front door. It's at the instance level.
And this one is stateful.
So it remembers the pizza order perfectly.
Yeah.
Your server sends a request out. The security group makes a note. When the reply comes back, it says, "Oh, I remember you. Come on in." You don't need that separate inbound rule.
That sounds so much easier to manage.
It is. That's why most of your day-to-day work happens at the security group level. It's just less prone to error. But there is a catch.
Of course there is.
Security groups are allow only, Firewalls.
Allow only, so I can't block that bad guy we talked about.
Not with a security group, no.
Yep.
You can't create a rule that says, deny IP address X. You can only list who's allowed in. By default, it's a sealed room. You just punch holes for your friends.
I see. So you can't explicitly ban an enemy. You just don't invite them to the party.
That's the perfect way to put it. NACL is for blocking bad guys. Security group is for inviting good guys.
Okay, this is making sense. We've secured the pipes. But hackers aren't just banging on the front door, they're tricking the application. This brings us to active defense and the WA.
The web application firewall. Right. We're moving up the stack now.
Yeah.
NACLs and security groups, they check ID cards, ports, and IPs. They don't look inside the package.
And the WF does look inside the package.
It does what the notes call deep packet inspection. It's looking at the actual web conversation, the HTTP and HTTPS traffic itself.
What's it looking for?
Patterns that look like attacks. The notes list a few things. Country of origin, header values, even how long the request is.
Yeah.
But the big ones are things like SQL injection.
Right, I've heard of that.
Imagine a login box. A normal person types Bob. A hacker might type a piece of code that says delete database.
Yo.
A security group just sees traffic on the right port and lets it in. But the WF reads the text. It sees that code and says, wait a minute, that's not a name, and it blocks it.
It's like a spell checker for malicious intent.
That's a great analogy, yeah. It also handles things like cross-site scripting or XSS. It's your content filter.
Okay, now what about just getting overwhelmed, like a DDoS attack? Does the WAF handle that?
It helps, but that's really the job of AWS Shield. The notes mention 2 tiers, standard and advanced.
What's the difference?
Shield standard is free. It's built in. You have it right now. And it protects against the most common network layer attacks.
So why pay for advanced?
Insurance. With Shield Advanced, you get 2 big things. First, 24/7 access to Amazon's DDoS response. Team actual humans helping you. But the second thing is financial.
Financial.
A DDoS attack means a massive traffic spike, which could mean a massive bill. Shield Advanced gives you cost protection, so AWS will actually wipe those charges if you get attacked.
That's a big deal. You're buying peace of mind. Speaking of big, what about something like AWS Firewall Manager? If I have 500 accounts, how do I keep all the rules straight?
That's the exact problem it solves. It's the manager for the herding of the cats. It lets you centrally configure and administer firewall rules across your entire organization.
Yeah.
You write one policy in a JSON format that says, for example, port 22 must be restricted on all servers.
And it just pushes that rule out everywhere.
It enforces it across your entire VPC perimeter. It ensures a uniform security posture no matter what some junior dev does in some sub-account.
That seems essential for any big company. Okay, so we fought off the hackers. Now for the scarier part, the auditors.
The paper trail.
This section deals with proving you're safe. First up, AWS Artifact.
Think of Artifact as your central library for legal documents.
So it doesn't do anything to the network.
No, it's where you go to get the proof. When a regulator asks for your SOC2 report or your ISO certification, you don't file a support ticket. You just go to Artifact and download the PDF.
Got it. Okay, then we have AWS Audit Manager, which sounds more active.
It is. If Artifact is a library, Audit Manager is more like a private detective. It continually monitors usage and automates evidence collection.
What does that mean, automates evidence?
In the old days, for an audit, you'd run around taking screenshots as settings. Look, the firewall's on. Audit Manager does that for you, constantly, in the background. It uses these pre-built frameworks for HAPO or PCI and just builds the case file for you.
So when the auditor shows up, you just hand them the report.
Exactly. It turns a yearly panic attack into a continuous calm process.
A massive time saver. Okay, next tool, one I think we can all appreciate. AWS Certificate Manager, or ACM. I've definitely seen that big red, your connection is not private screen.
And that almost always means their SSL certificate expired. Someone forgot to renew it.
It's so embarrassing.
It is. ACM solves that headache. But the key benefit, like the notes say, is automated renewal.
That's the magic phrase.
It really is. You integrate with your load balancer or CloudFront, and AWS just handles a renewal before it expires. You set it up once and forget it.
And it mentions wildcard certificates, too.
Yeah, that's great for subdomains. One certificate for .example.com can cover your blog, your mail, everything. Just simplifies management.
Okay, final section. We've built the fortress. We have the paperwork. How do we stay smart? How do we know we're not wasting money or leaving a window open? The notes point to AWS Trusted Advisor.
Trusted Advisor is like having a consultant looking over your shoulder in real time. It's an optimization tool.
And it checks more than just security, right?
Correct. It looks at cost optimization, performance, security, fault tolerance, service limits, and operational excellence.
Service limits is interesting.
It saves you from yourself. AWS limits how many servers you can launch, for example. Trusted Advisor warns you if you're getting close so you don't get a capacity-reached error during a critical launch.
And for security, it just tells you, like, hey, you left the front door open.
Pretty much. Hey, you have a security group open to the entire world on port 22. You should probably fix that.
Is this available to everyone?
The basic checks are, yeah. But for the full suite of security and cost checks, the notes clarify you need a business or enterprise support plan.
Good to know. Okay, what about when things go wrong on Amazon's side? Where do I look?
Twitter. You might think you just check the main status page, but the notes point us to the AWS Health Dashboard, specifically the Personal Health Dashboard.
What's personal about it?
The general page shows everything. If a server in Tokyo goes down, it lights up. But if your stuff is in Virginia, you don't care. It's noise. The Personal Health Dashboard only shows you events that impact your specific account.
So if my database is on a piece of hardware that's about to fail, this tells me.
Exactly. And it integrates with EventBridge and Lambda, so you can even automate a response. Like, if my server is degrading, automatically launch a replacement.
That's self-healing infrastructure. Incredible. Okay, last thing. For listeners who want to keep learning, where do the notes say to go?
3 main places.
Sure.
For troubleshooting, the AWS Knowledge Center, which is now part of AWS Repost, that's your FAQs and community help.
And to stay current.
The AWS Security Blog, that's where you get the real-world solutions from the experts at AWS.
And finally, if you just want to buy a tool,
The AWS Marketplace, for third-party security solutions. But there's a funny detail in the notes about the star ratings.
right, that they're often from free trial users.
Yeah, a good reminder to take those ratings with a grain of salt. Someone who used it for a day might have a very different opinion than someone who used it in production for a year.
Always read the reviews carefully. All right, let's bring this all together. We've covered a lot.
We really have.
We started with the network plumbing, the NACLs guarding the subnet and the security groups on the instances, then the active shields like Wave Shield. We did the paperwork with Artifact and Audit Manager and finished with optimization using Trusted Advisor.
It's a comprehensive ecosystem. It's not one tool, it's how they all interlock.
So before we go, what's the one big thought you want to leave the listener with?
We talked a lot about automation today, and automation is fantastic.
Yeah.
But it brings up a question. Who is watching the dashboard?
What do you mean?
The tools give you the data. They provide the what. Trusted Advisor can tell you a bucket is public. But maybe you meant for it to be public. The tool doesn't know your intent. The tools provide the data, but the human element, you, the listener, you provide the judgment. You provide the why.
That's a great point. Automation without oversight is just a really fast way to make a mistake.
Exactly.
Well, that's a wrap for this deep dive. I encourage you to log into your console today and check your own security group rules. See if they're actually stateful or if you've just been lucky. Thanks for listening.
Stay secure, everyone.